Safety Interlock System SIS in Petrochemical Industry. These are my group members. Me, Marisa Valentina, Nur Alicia Eliana, Siti Nur Sabrina, and Felicia Dolina. I will start first. Safety interlock system SIS in petrochemical industry are engineered control designed to automatically present hazardous event by ensuring safe shutdown or activating protective measure when specific conditions arise. This system include various types such as emergency shutdown system ESD, process shutdown system PSD, and fire and gas detection system FNG, each with a specific role in mitigating risk. In our presentation, we will also cover fundamental knowledge of heat exchanger theory, exploring how heat exchangers are integrated within this system. Additionally, we will discuss key safety awareness practices to follow when working with interlock system to ensure personnel and equipment safety.
I am Sitino Sabrina and I will talk about knowledge of heat exchanger theory. Heat exchangers are devices that transfer heat between two fluids. They can transfer heat between a liquid and a gas, example, a liquid to air heat exchanger, or two gases, example, an air to air heat exchanger. Or they can perform as liquid to liquid heat exchangers. These devices are used in many applications, such as air conditioning, gas turbines, automobiles, and electronics cooling. For example, the radiator in a car is water to air heat exchanger that cools the heated water returning from the engine. Heat exchangers can be subject to various failure modes, such as falling, leaks, or thermal stress, which can compromise the integrity of the system. By integrating SIS with heat exchangers, the system can ensure that if the heat exchanger deviates from self-operational limits, protective actions are triggered. For example, if the temperature in a heat exchanger reaches a critical level, SIS can shut down the process and activate cooling mechanism to prevent further escalation.
I'm No Alisha. I'll be talking about safety awareness. First is personal protective equipment (PPE). Follow plant policy for PPE such as safety goggles, glove, and respirator mask. Next is shut off and isolate. Ensure all inlet valves are fastened and tagged, and close the supply and return water valve. Third is visual inspection. Check for visible signs of damage such as corrosion or cracks. Six is pressure release. Use a safety relief device to reduce the heat exchanger pressure to zero. Next, gasket installation. Carefully install a new gasket to avoid leaking. Next is visual inspection. Check for visible signs of damage such as corrosion or crack. Lastly, empty chemicals. Remove any dangerous or chemical from the heat exchanger.
I'm Felicia and I will conclude our presentation. In the petrochemical industry, safety interlock systems are vital for ensuring safe and efficient operation. By integrating SIS with critical components such as heat exchanger, companies can be better prevent dangerous conditions from developing. By automatically intervening when dangerous conditions arise, SIS help to minimize risks associated with high temperature and high pressure process, particularly in sensitive equipment like heat exchanger. The integration of SIS with process equipment ensures that any deviation from safe operation in condition are quickly addressed, protecting both personnel and the environment. Furthermore, fostering a culture of safety awareness through regular maintenance, training, and emergency preparedness amplify the effectiveness of SIS.
Thank you.